going here. Okay, I think we're up and running here. So I was responding to comments in the chat about the lab. Yeah, I just tried to log in. Let me try one more time. Go to Google Apps, HDHD, and I get a Google 505. Well, 500, not 505. What's a 500 error? Let me Google a 500 error. Very general status code means that something has gone wrong. Well, obviously something's gone wrong on the web server, on the website server, but the server could not be more specific on what the exact problem is. So there's something wrong with this website. So I don't know. Well, I can always push the due date back until they get things fixed. It looks like it was working and now it's not working. So that was, when is that due? It's not due till the 19th, I think. Wait, no, 14th. It was due on the 14th. So you got 2 more days to do it. If it's still messed up by the 14th, I will put the due date back. So don't worry about the lab. But speaking of assignments, I did post your next homework assignment, Chapter 4 homework. Still got a few more topics to go through. We're just starting. Well, hopefully we'll get through most of the, there's still some more stuff. I don't know how enough time today to get through all of the projectile motion stuff, but we still have to do uniform circular motion and relative motion before we get out of this chapter. Okay, so take a look at that homework assignment, and then just, I don't know, just keep trying back to throughout the day. I don't know when did this 500 errors start occurring? I don't know. I mean, I tried going on last week, but I don't remember I went on Friday or not. Okay, so maybe it's something when their server went down over the weekend, probably. Yeah. All right. Well, it's Monday, so they probably were all home on the weekend, so they probably didn't realize it was broken until they came in this morning. So maybe they'll have it back up today sometime. So try later today. Okay. All right. Any other issues that I need to know about? Okay. All right. So let's see how much we can get done in the short period we have today. Another couple of problems on projectile motion. These are a little bit more challenging problems. Though I'm just probably going to get this one problem done today. And then the only other thing I've got for you in projectile motion is this thing called the range equation, which so I'll probably have to wait till tomorrow to do that one. All right, so here's the problem. You've got a slope, a hill, right? Like there's a flat plane, and then all of a sudden from the flat plane, a 30 degrees hill goes up. It's just a straight 30-degree hill. So visuals are nice. So where's my, so what am I talking about here? Something like that, right? Okay. And the cannon's located right at the bottom of the hill, right? And you fire the cannon and it goes up the hill, it lands somewhere up the slope, okay? So the slope is 30 degrees, the cannon is fired at 45 degrees to the horizontal, and the initial velocity is given. Question is, how far up the slope will the cannonball land, okay? And then the second question is, what is its speed as it impacts the ground, okay? So 2 questions to answer on this problem. And like I said, it's a little bit more complicated than your usual projectile motion problem. Here's another drawing I made, okay? So that maybe that last drawing didn't do it for you. Maybe this one will explain what's going on. Cannon's going to be very, very tiny, and you're just going to assume that the initial position is going to be right at where the slope starts, okay? That's going to be the initial position there. And then you have an initial velocity vector that's at 45 degrees to the horizontal, okay? and the slope is 30 degrees. So what's going to happen? So the object's going to go up, and if you remember, projectile motion is basically the velocity in the horizontal direction remains constant because there is no acceleration in the x direction. And in the vertical direction, you have a constant acceleration downwards of 9.8 meters per second per second. Okay, so put those two together and you get basically the object falls in a parabola towards the ground. And so basically this is, we're trying to find the point of impact here. And we'll set up the equations, but mathematically, how would you think about this problem? This is the physics of what's going on. You're actually physically shooting some sort of object and it lands, in a puff of smoke up on the hill somewhere. But mathematically, what we're doing is we're going to be setting up the equation of motion for the object and then somehow mathematically finding the intersection of this slope, this line with that guy there. And we're not going to exactly do like, you could, I suppose, you could set up that line, the equation of that line, that slope, as a line, and then solve this two things simultaneously. But there's another way using trigonometry that's actually a little bit easier. So that's what we'll do. All right, so how do you set up the equations? Well, first thing is we're going to need those initial velocity components, right? And so if you remember, you've got these formulas memorized, right? AX equals A cosine theta, AY equals A sine theta, okay? And you apply that to the information given. And so the magnitude V0 of the initial velocity vector is 50 times the cosine of 45 is 35.4. And then because the angle is 45, you get exactly the same component in both directions, right? And if you have a 45-degree triangle, right triangle, the opposite side and the adjacent side are the same length, right? Same thing here for the initial velocity vector. V0x and V0y have to be the same value. That kind of make sense, everybody? Any questions on that? Okay, so where do you go from here? Let's start with the x. This is another one where well, the first part of the question asks like how far up the slope. So that's asking information about the position of where something's going to be. The second part asks what is the speed as it impacts the ground. So the second one, hopefully this is making sense to you guys now. Like which equations do you start with? Well, if you're given information or you're asked information about where the positions of the objects are, then you're probably going to use the position equation. If you're given or asked information about what the speed or the velocity of the object, then you're probably going to have to end up using the velocity equations. Okay. But in either case, we have to figure out what AX, V0x, and X0 is. I think by now you've had enough experience with this. AX is always 0, right? AX is always 0. V0x, we just figured that one out. And X0, where's the initial position? Well, I think I already mentioned. I think that it does it make sense that probably the best place to put the origin for a coordinate system is going to be at right where it's fired from? Does that make sense for everybody? I suppose you could make it the impact point, but that would make your life really miserable. Because that means you're going to have to go back and figure out what those initial positions are, in terms of, the slope and the angle and everything. That would just be a mess. So this is typically, what you do. You put the origin of your coordinate system. And I think you saw that in some of the projectile motion problems, like, the animals being, launching off a building or whatever, that it makes life easy if you just put the origin at wherever the problem starts. So anyway, if you put in A, I just kind of skipped a few steps here in the interest of saving pencil lead. So AX is 0, X0 is 0, and V0x is 35.4. So that the X equation just reduces down to 35.4 meters per second times the amount of time. And that's, again, just reiterate this, that's projectile motion. In the X direction, you travel at a constant speed. There's the constant speed, you multiply it by the time, and that's how far you've gone in the X direction, okay? And in the Y direction, there is going to be an initial, there is going to be an acceleration in the vertical direction. Again, so we know that because we're calling it 0. I'm going to call downwards negative and upwards positive, because both of our initial velocity vectors components are positive. So since I called that positive and that positive, I've already made a choice as to which direction along the axis are positive and which one's negative. V0x is positive 35.4. That means to the right in the drawing is positive. And if V0y is positive 35.4, that means up in the drawing is positive. So that means that down's got to be negative. Does that make sense to everybody? Any questions on that? Okay. So plugging all that in, that's what's left over in the y direction. Okay. All right, so where do you go from here? Go back to the drawing and take a look at that, stare at it for a long time, and then say, okay, positions, x position, y position. What am I interested in? I'm interested in that point up there, right? And so in the x direction, it's gone that far. In the y direction, it's gone that far, right? Well, everybody see the triangle? If that's x of t, and that's y of t, and that's d, like I called it in the drawing, then doesn't that make a little right triangle? Because you got to find a relationship. You got to put the x of t and y of t together. Okay? So, does that make sense to you? I'll write that down. And where y and x in this equation are the same as these guys. This is, I could have put y of t and x of t, but I just didn't want to make the equation too messy. But that's basically the expression, the relationship between y and x, right? If I take x and divide by y, I'd get tangent of 30. So y should be able to it should be equal to x tangent 30. Make sense? And so that's how you find the impact point. Like I said, you could have done the other route, which is, you know, it would have been a mess, but it would have taken a lot more algebra, and this is a lot simpler way, an easier way of getting to the solution. Okay. All right. So all you gotta do is just plug those in, right? So if you didn't know, the tangent of 30 is 0.58. So if you're wondering, like, where do you get the 0.58? That's just the tangent of 30. So the x equation, can I keep it all here on the screen? There's the x equation up here. So you multiply that by the tangent of 30, which is 0.58. So you see that on the right side of the equation. And then on the left side of the equation is just the y equation. So now we have just an equation in t to solve. All right, any questions on that so far? See how I did that? Keep track of the time here. Okay, so luckily, there is no constant in this equation. That makes my life much easier. Why? Because I can factor a t out, and I don't have to use the quadratic formula. Does everybody know what I meant by that? Like, if you solve this equation, this is t squared, so there's going to be two roots, but because there's no constant equation, one of those roots is going to be what? It's got to be, right? I'm going to factor a t out. That's okay. You remember this stuff from algebra class? Okay, good. All right, so I just wrote it down. I mean, if you need to see how I did this, basically, you know, it's like if I could take that equation, I could factor a factor of t out, and then I'd have 4.9 times t minus 14.9 in one parentheses, and then in the next parentheses, multiplying it would be just t, and both of those multiplied together would be equal to 0. So that means either of those parentheses could equal 0, and that would be a solution. So one of the roots is 0, and the other one, if you do the math, it'll be what? It'll be 14.9 divided by 4.9, and that works out to 3.04. Okay, now what is the, why do I get t equals 0 as a solution? Why did that pop out? It's a mathematical artifact of what I'm asking the equations to tell me. Is my question make sense to you guys? Yeah, it's just right. It's when it's launched, right? basically it's asking when does this projectile intersect this line? And it intersects one time up there, but it also intersected the line at the origin too. So that's why you get that 0 in there, okay? All right, so you plug that in to the x part, right? And I could also plug the time into the y equation, right? And I should get 62.7, but since I already know that y is equal to 0.58 times x, I went ahead and I plugged the x into this guy. That makes sense. I could have plugged it into the y. I could have plugged the time into the y equation, and I should have got exactly the same thing. You're wondering how I got that. All right, but that's not the answer yet. That's just, this is the x position. This is the y position in the coordinate system. What they're asking for, though, is that distance up the slope. That's basically the hypotenuse of that triangle. So yeah, that makes sense, what I did there? If, x is the distance along the x-axis and y is the distance up along the y-axis, and, it makes a right triangle, the hypotenuse is what is the distance up the slope. And so I just find the hypotenuse of that triangle, x squared plus y squared, and take the square root. So the answer is 124.4 meters up the slope. Any questions on that one? Okay. No questions? All right, good. All right, so let's move this up a little bit. All right, now, how fast is it going? What is its speed when it hits the slope? Now remember, I specifically used the word speed, right? So that's not velocity, which would include the direction. So all I really need to do is just find the magnitude of the velocity vector. Does that make sense what I just said? That's what the speed is, the magnitude of the velocity vector. Okay, so how am I going to find the magnitude of the velocity vector? Well, I'm going to need to know, hopefully you've seen this enough now, you know this is how this stuff works. If you think back to all that vector stuff we did, and I kind of made a big deal about, okay, here's the magnitude and direction form of the vector, here's the component form of the vector, and you go back and forth. So you can see how this works. Is the problem set up in magnitude and direction form, but to do the math, to do the physics math, to use the kinematic equations, you have to, the kinematic equations involves the components of the vectors. So you got to bust the vectors into their components, plug them into the equations, solve, and then you got to go, a lot of times you got to go backwards. And you got to, from the components, you got to figure out what the magnitude and direction is. In this case, I only need the magnitude. Okay, so get rid of that. All right. So I don't know, we've done a lot of work with the velocity equations. They're pretty straightforward. The AX and the V0X are exactly the same as the same numbers as they were in the X equation. They're the same thing. This is the acceleration component in the X direction. This is the X component of the initial velocity vector. And then you just fill them into the equation. And then this would be the X component of the velocity vector at any time t. All right, so like I said, we don't do the vector mathematics, pulling the vector mathematics throughout the problem, but you got to think of everything in vector terms. All right, so again, I'm going to reiterate this twice, this period. In the X direction, the way projectile motion works is, in the X direction, the velocity is always constant. So in Vx is going to be whatever V0x is, because Ax is 0. So that's always going to be true. Okay, in the Y direction, it does change, but only, due to that constant acceleration AY. So plug that stuff in. I need to find the Y component at that time of impact, which is 3.04 seconds. So again, using the same plus and minus signs that I set up before, 35.4 is going to be positive upwards. Gravity is going to be negative 9.8 downwards. And I get a velocity of 5.6 meters per second, which is kind of interesting. Obviously, I drew the drawing wrong. Did you catch that? Let me put the drawing back on here. See, I did the drawing wrong. How do I know that? What's wrong about my drawing? Think about the velocity vector, what direction it's pointed when it hits the ground up the slope. No? Nobody wants to take a stab? Okay. As drawn there in the drawing, if you had to draw a little vector there at x that was tangent to that parabola, it would be kind of pointed downwards, wouldn't it? I mean, the y component would have to be negative, but the y component's not negative. So I actually should have drawn this so that it intersected the dashed line on the way up, not on the way down. Hopefully that made sense. Okay. Anyways, we're going to find the velocity vector component, the magnitude of it anyway. Again, take the components, those Vx and Vy are the components, square them, add them together, take the square root, and that's how you find the magnitude of a vector. So that's the speed when it impacts the hill, 35.8. Okay. Any questions on that? Yeah, I don't think I can do this other problem. I don't think I got enough time. Nope. I don't want to get stuck and not give you any time at the end of the period. Okay, so any questions on this? So I think this is all I'm going to be able to get done today, even though I do have a little bit of time, but I don't have enough time to do this next problem. So we got plenty of time tomorrow. All right, any questions? Hold on, let me double check. Let me try one more time, see if I can get into the lab thing. See if they got it fixed yet. Bang, crash, boom, blam. Nope, it's still crashing. How did I get x tangent 30? Okay, so let me make a little drawing here. 30 degrees, right triangle, y of t, x of t, and then d. Okay, so put it up here. Right? I mean, when it hits the slope up there, it's at a distance d up the slope, right? So, and that's the distance I'm interested in, and it makes a right triangle. So what's y divided by x from trigonometry? That's it. I mean, that's the impact point. This is the origin. Okay, it starts from there and it lands there. So how is x of t and y of t related? They're basically, that's the sides of a right triangle. Does that make sense? Okay, good. All right. Okay, let me go back and let's say, okay, so I don't see any other questions. All right. Okay then, guys, that is it for today. A little, about 15 minutes for your next class. All right. Unless there's any other questions, we'll see you guys tomorrow.